Ever wondered how to project one vector onto another in mathematics? Well, today's your lucky day. We're going to explore the wonderful world of vector projection. Imagine a vector, let's call it A, and we want to project it onto another vector, let's say B. This projection, often denoted as proj BA, represents the part of A that lies along the direction of B. Simple, right? But it gets better. This projection is always orthogonal or perpendicular to B. It follows the direction of B, and its magnitude equals the dot product of A and B divided by the magnitude of B. And let me tell you, this concept isn't just fun to talk about, it's incredibly useful. It pops up in defining the orthogonal projection of a vector onto a subspace and in calculating forces and torques in physics. Now let's delve deeper and learn how to calculate vector projection. So, how do we calculate the projection of one vector onto another? Well, it's as simple as this formula. Proj BA equals a dot B multiplied by B divided by the magnitude of B squared. Now let's break this down a bit. Here, A and B are our vectors. When we say a dot B, we're talking about the dot product of A and B. It's a scalar quantity obtained by performing specific operations on the corresponding components of vectors A and B. Now, the term B divided by the magnitude of B squared might seem a bit complicated, but don't worry, it's not. The magnitude of a vector is simply the length or size of the vector. It's a non-negative scalar that describes the extent of the vector in space. And there you have it. That's how we calculate the projection of one vector onto another. All right, we've got the formula. Now let's put it to work. It's time to see our formula in action with a couple of examples. Our first example involves finding the projection of a simple vector, let's call it vector A, onto another vector, which we'll name as vector B. Say vector A is 1, 2, 3 and vector B is 2, 3, 1. After computing the dot product and dividing by the magnitude of B squared, we get a projection of 1.8, 2.7, 1.2. Fascinating, isn't it? Moving on to our second example, let's find the projection of a vector onto a plane spanned by two vectors. We have vector A as 4, 0, negative 3, and vectors B and C as 1, 2, 1 and 2, 1, 2 respectively. By finding the orthogonal vector and then the projection of A onto it, we get a final projection of 2.72, 5.44, 3.28. And that's how you calculate the projection of one vector onto another. It may seem complex at first, but with practice, you'll be a pro in no time.